So when we're talking about gathering data, it means that we're gathering numbers from maybe surveys or just research that we kind of listened to and tried to figure out. If you look at the next couple of information, data is a collection of information. You observe, you question, you measure, and you gather this and organize it either as a graph or as a chart. The first type of chart or plot that we're going to talk about, you may never have seen or may never have learned about, but you may have seen on some standardized tests. This is what we call a stem and leaf plot. A stem and leaf plot is actually numerical data that's listed in ascending, which means increasing, or descending order, where the greatest place value of the data is used as the stem, and the least place values are used as leaves. Let me give you an example. Here in this table, you will see the average weight of different breeds of dogs. So if you look at the data itself, you notice that we have a dog that's 10 pounds, 21 pounds, 15, 9, 17, and so on. If I was to organize this data to make it easier for me to make sense of it, what would be the first thing I would have to do? You would want to organize it from least to greatest so you could see a little bit better. Now, if you did this, you would list probably 8 is the first, no, actually 4. It would go 4, then 6, then 8. We have 2 9s. The next number would be 10. Then we would have 11. Then I see 13, 15, 17, 18, 20, 21, 24, 25, and 26. What do you think would be the next thing I would have to do just to make sure that I have every item? You might want to count how many there are. 1, 2, 3, 4. 1, 2, 3, 4. So 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know I have all of them. Now in a stem and leaf plot, like they said, the stem is the largest place value. The leaf is the smallest. What is the largest place value that we get to here?
26.
The tens place, which is 2. 2 is for 20. So we have our stem of 0 because we have numbers such as 4, 6, 8, and 9. So we write 0 for the stem because there's no tens, and 4, 6, 8, 9, and 9 as the leaf. The next place value is the tens place, 10, 11, 13, 15, 17, and 18. So we write the 1 for stem, and then 0 for 10, because 10 is a number. 1, 0 is 10. 1, 1 represents 11. The 3 here represents 1 and 3, which is 13. 1 and 5, which is 15, 17, and 18. And then 20, we have 2 and 0 for 20. 21, there's a 1, a 4, a 5, and a 6 to represent 21, 24, 25, and 26. Now you also have to make sure you always write a key. 2/6 represents 26 pounds. You have a title, you have the stem, the leaf, and the key. This is a stem and leaf plot. The next part of information that we're going to talk about is a little bit more mathematical. This is, first of all, when we gather data and we list it from least to greatest, so this is a different set of data, the median is literally the number right smack in the middle of all of them. So you have to list them from least to greatest. And then you kind of go out from the outermost, so 5 and 0, 0 and 5, and you keep going until you get right smack in the middle. Now, if I showed you how to do this, we would say not these two. You go from the outer and work your way in. When you get there, you notice that there's two middle guys. And the median is that number there. Well, there is no number there, but to find the median of two numbers, you add them and divide by 2. In this case, 2 plus 2 is 4, divided by 2 is 2. So in this case, the median is a 2 that's really not there, but it represents what the middle number would be. Now, if you have an odd number of numbers, you're going to have a perfect median. So for example, if I had something like 1, 2, 3, 4, 5, 6, 7, the median would be not these, you work your outside in, it would actually have to be, let's say 6. It would be this one right here. The 3 would be the median. So if you have an odd quantity of data, you will be able to find the perfect median. If you have an even quantity of data, you're going to have to add the two middle numbers and divide by 2. Let's go back to our median up there. Once you find your median, which would be 2 in this case, because the median of 2 and 2 is 2, you then divide your lower half. This is your lower half of the data. And your upper half of the data. The median of the lower half is what we call the lower quartile. So once you divide your data into the lower half and the upper half, you divide the lower half into halves as well by doing the whole median thing. So you would take this 2, you would count it within the median of the within the lower half. So it would be none of those. You keep on going, keep on going, keep on going, and you would realize that the median of that is also 1. Because 1 plus 1 divided by 2 is 1. Then you do the same thing to the upper half. You count for your median, so not the other 2. You start from your outside looking in. You realize that your median is going to be between 3 and 4, which is? What's between 3 and 4? 3.5. Remember, 3 plus 4 divided by 2. The middle of 3 and 4 is 3.5. So the upper quartile, which is called the median of the upper half, is 3.5. Okay, so let's do this again. List of data. You separate it into 2 halves. The median, whether it is spoken or has to be found, of the whole data separates the whole data set into the lower half and the upper half. The median of the lower half is called the lower quartile. The median of the upper half is called the upper quartile. Once you have these special numbers, you can then translate this stuff into what we call a stem and leaf plot. I'm sorry, a box and whisker plot, not stem and leaf. That was the other one. A box and whisker plot. The box and whisker plot takes data and makes literally a box and whiskers out of them. The data that we have up here that we just separated into halves, you would draw a number line. You would say that the median is 2, because that is what the median is. The lowermost value is 0, 0, 1, 2. The highest is 5, 3, 4, 5. And because the lowest is 0, you put a dot at 0. And the highest is 5, you put a dot at 5. You then put a dot that represents the median, which is 2. That would be right here. That's the median. You put a line through that to represent visually that that's your median. Then you draw, or you put a point at your lower quartile, which is 1. You put a line through that, and you put a line through your upper quartile, which is 3.5. Well, if this is 3 and this is 4, 3.5 is going to be right about here. And you put a line through that. Now you make a box out of those 3 lines. And then you make whiskers to extend out. This is what we call a box and whisker plot. So once we find the box and whisker plot, we can actually look at the data without even having the data in front of us. So we're going to move over to another one so that you guys could see. A lot of times in athletics, in sports, they actually use box and whisker plots for gathering statistics. If you look at this here, this table is actually showing you the number of wins that the Boston Red Sox had from 1996 through 2007. Okay, if you look at all of the data itself, it tells me here that in 1996 there were 85 wins, 78 wins in 97, 92, 94. The data that's down here represents the number of wins. The numbers that are above that is the year that it happened in. So if we organized this data from least to greatest to create a box and whisker plot, what you would do is you would literally first organize it from least to greatest. So let's list that data from least to greatest. So the lowest number is 78. Then we move through and we get 82. Then 85. Then 86. Our next number is 92. 93. 94. There's 2 95s and a 96. We count to make sure that we have the right amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm missing 2. 98, thank you. And there are 2 85s. So I need to throw an 85 in there. Now I have them all. Okay, now that my data is organized from least to greatest, now the box and whisker plot is up there for you to see, but I want you to see how it is that we did this. Okay, once we have the data listed from least to greatest, we create a number line, and our number line is ranging. There's another vocab word. The word range is the lowest taken away from the highest, but the lowest is 78 and the highest is 98. We want to make a number line that is well represented with increments in between. So we're probably going to count by what, 2s or by 5s potentially. So if that one is 78, let's start with 75. And this one would go up to probably 100. So 75, 80, 85, 90, 95, 100. And the lowest point, you start with the lowest point, which is 78, which would mean that it's somewhere between 75 and 80. So right about here. That's your lowest point. That's your minimum value. Your highest point is 98, which would be right about here. Now you need to find the median of these list of data. So you go from out in. So not these two, not these two, not those, or those, or those. It's not either of these. It's going to be right smack in the middle. What is between 92 and 93? 92.5, correct? This is the median of the whole data set. This is where we divide our lower half from our upper half. 92.5 needs to be right here. That's the median. We're going to draw a line through there so we know that that's the middle one. And we might put 92.5 up here. Now I need to find the median of the lower half. So when I do that, same thing, outwards going in, not these two. Remember, you always count the last one, like 92. Not these two. It's going to be the middle of 85 and 85, which happens to be 85. That is the lower quartile. The lower quartile is the median of the lower half. Then we do the same thing with the upper quartile. Not 93 or 98 or 94 or 96. It's going to be between 95 and 95, which happens to be 95. That's the upper quartile. Put a box around upper and lower quartile where the median is right smack in the middle. Extend your whiskers out and you have yourself your box and whisker plot. The last type of display that we are going to talk about is a histogram. A histogram is often confused with a bar graph, but it is not the same thing as a bar graph. The only similarities it has is that it uses bars. A histogram uses bars to display numerical data that has been arranged in intervals. An interval is a group of numbers. So for example, if I was going to list the ages of people in the middle school, I'm not going to list 10, 11, 12, 13, 14, 15. I might say 10 to 12, 13 to 14. Those are intervals. And there's no spaces between the bars. So if we look here, somebody gathered data about how old certain people were when they were walking into a specific store. You notice that the intervals are down at the bottom. Ages between 1 and 10, 11 and 20, 21 and 30, and so on. The intervals have to be equal. So that means that if there's 9 items between, or 10 items between 1 and 10, there's got to be from 11 to 20, and so on. You can't say 1 to 10 and then 11 through 19 because that's not consistent. So your job would be to figure out what the intervals are based on the data that you gathered. And then in order to figure out how much there is within each interval, you find the frequency. And that frequency is collected using a frequency table. So if we were sitting outside of that store trying to see how many people walked in on a specific day, we might tally on our frequency table how many kids between the ages of 1 and 10 there were. Every 5 we make a little slash through it to represent 5 is the frequency, 8, 14, and so on. And then the data is transferred from the frequency table to the histogram, where the tallies are just working information. It just helps us figure out how much of each we have. And then we also make sure that we have our data on the y-axis properly written down so we know it's like from 0, 2, 4, 6, 8, 10, 12, and so on. Okay? So, with that, when you are asked to find the interquartile range, looking back at the data of the Boston Red Sox wins, if we were not given the data above and you were only given the box and whisker plot, you would be able to find all of the values. So if I asked you what is the median, even though it says it here, you would be able to look at the fact that the median is the one right smack in the middle, and you would be able to estimate it's about 92.5. When they ask you for the range of the data, the range is the largest amount, the maximum value, minus the minimum value. So in this case, it would be 98 minus 78, which is 20. The range is 20. But there's also a thing called interquartile range. Interquartile range is the difference between the upper quartile and lower quartile. Because remember, the upper quartile is the median of the upper half. It's the middle of the upper half. So the upper quartile in this case is 95. And the lower quartile is the median of the lower half, which is 85. The interquartile range is the upper quartile minus the lower quartile. So in this case, the upper quartile is 95. The lower quartile is 85. So the interquartile range is 10. If we look at one of the problems from MathSpace, you notice that they give you a box and whisker plot, and they don't give you any of the data. Your job is going to be able to identify the minimum value, the maximum value, the lower quartile, the median, and the upper quartile. The minimum value, if we look at it here, is 2. The maximum value is 17. The median is the one right smack in the middle. That would be this one right here, which is 11. So the median of the entire data is 11. The lower quartile is the median of the lower half. That is 8. The upper quartile is the median of the upper half. In this case, it's 15. The range of the data is the range of the entire data. So when we're looking at the range of this data, it's going to be 17 minus 2. The range is 15. The interquartile range is the upper quartile minus the lower quartile. So that would be 15 minus 8, which is 7. What this is saying is that there's 7 units between the lower median and upper median. So even though you have a big range of 15, most of the data is really kind of close together. It's within this group of numbers. So there's really only 7 units between the lower and the upper quartiles. So it's kind of pulled together towards the right, towards the higher numbers. This might be a little bit of an outlier or a little bit off.